Okay, so besides financially supporting the conference, the sponsors also provide some great speakers. And without further delay, I'd like to introduce our first keynote speaker this morning, Robert Hodges, who is the CEO of Continuent. Robert has over 30 years of experience in database and application engineering. And prior to Continuent, he worked on object relational databases and transaction processing at Sybase. He also held senior engineering positions at Portera and Exogen Group, where he designed and operated software as a service applications. Robert is the original designer of Continuent's Tungsten solution. I'd like to join me in welcoming Robert to the podium. Robert?
Thanks, Derek. Hi, everybody. Good morning. Great. I have audio. Just a little bit of housekeeping before I forget. I'd like to also thank Percona for organizing this conference, and I'd like to call out, as Peter already did, Terry and Courtney. You guys do a wonderful job of organizing these conferences. I've been to a bunch of them. They get better every year. So I think we all owe these folks a vote of thanks for creating this venue and this ability for us to come together and talk about this technology. I'm going to be talking about MySQL and Hadoop this morning. And you may not have noticed this, but because there was a flurry of announcements, but yesterday we announced a brand new feature in the Tungsten Replicator, which is one of our main products. And it's the ability to replicate data out of MySQL into Hadoop. This is going to be Tungsten Replicator 3.0. So it was announced yesterday. If you haven't seen it, check your spam email boxes. It's a serious announcement, even though it was on the 1st of April. But I'm actually not going to talk about that so much today. What I'd like to share with you is some of the lessons that we have learned about integration between MySQL and Hadoop as we were developing this product, and more importantly, as we're working with customers out in the field. So I'd like to answer some questions about this, and I think the first question is a really important one, which is, why should you even care about Hadoop? And I wonder just how many people in this room work for companies that run Hadoop clusters? Okay, that's a good number. So already you care because probably your managers care about it. How about for those of you that don't have Hadoop, how many of you are thinking about Hadoop? Okay, so that's some more. How many of you have no idea what Hadoop is? Okay, this next slide is for you. Well, actually, it's for everybody. What is Hadoop? So, as everybody knows, Hadoop is an elephant. It's the elephant that Doug Cutting's son owned, and that's how the project was named. But Hadoop is a new way of doing analytics. And if you come and look at it for the first time, as I did probably 8 or 9 months ago, it's a tremendously complicated set of technologies, a bunch of very quickly evolving projects, kind of loosely integrated, but they're all designed to help analyze data. And Hadoop at its core has two very important features that are the foundation, in other words, the rock on which the rest of Hadoop is built. The first feature is the Hadoop distributed file system. So what this does is it is a file system that runs on a bunch of nodes and allows you to spread data across hundreds or even thousands of hosts running commodity disk drives. So what this does is it opens up the ability to store massive amounts of information, have it replicated across numerous locations, deal with failures, and basically be able to do this very cheaply. The second thing that's in the core is MapReduce. And MapReduce is a programming model that allows you to access this data in parallel very efficiently. So in other words, exploit the fact that you may have dozens or hundreds or even thousands of computers with this distributed data to answer interesting questions like, can I correlate Twitter posts about my product with sales? These are things that people would like to integrate and know about. On top of this, we have a whole host of other projects which build on it. Some of them are better ways of doing MapReduce, that's like Spark and Storm. Some of them are infrastructure projects that just make things work, like Scoop, for example, is a program that many of you are already using to move data from SQL databases into the Hadoop file system. And then finally, the green spots that we have on this picture are just a bunch of projects to help you do analytics. For example, Hive creates a SQL interface on top of raw Hadoop data. There are many others like this, and constantly new ones appearing almost every day. So this is Hadoop. The next question is this good? Well, some people think it is. Just in the last week or so, there's been announcements of close to $1 billion in funding. So there's certainly some people out in the marketplace that think they're going to be making a lot of money on this. For us in this room, that's not necessarily the right answer. I think we all know that in Hollywood, you can spend a lot of money on movies. Sometimes they're good, like Avatar. Sometimes they're really bad, like Ishtar. So the question is Hadoop more like Avatar, or is it more like Ishtar? There's a lot of money going into this. For my part, I think it's more like Avatar. And let me give you some reasons why. What is it that Hadoop really does that's different? The first thing is it analyzes any kind of data. This is really profound. If you're dealing with data warehouses, traditionally many of them have been set up with SQL. The data had to be in relational tables. Well, Hadoop can analyze anything. It could be the Twitter fire hose. It could be sensor readings from warehouse thermometers. It could be server logs to do that you're looking at for intrusion detection. All of this can be fed into HDFS and analyzed together. So this ability to analyze any kind of data and have it all in the same place is a fundamental change in the way people do analytics. So this is good. There's another very good thing about Hadoop, which is that loading is very simple. In this slide you're seeing, kind of fine print, that's all you have to do to load a MySQL table into the Hadoop file system. This turns data warehousing. How many of you have done data warehousing projects? So if they're not in Hadoop, they are complicated projects. You need to set up schema. You need to do a lot of groundwork before the first bit of data gets into that data warehouse and starts to generate information. In Hadoop, you can load the data almost instantly, and then what you do is build structures on top of it as needed to do your analytics. So this means that you can dump the data in and in some cases almost immediately begin getting value out of it. It turns data warehousing on its head. A third thing, Hadoop itself is implemented very cleverly. So everybody knows that storage is getting cheaper. Disks, last time I looked, are about 4 cents a gig, something like that. We all know this. But the thing that Hadoop does is it uses this knowledge. And for example, if I have a file that's, say, a terabyte, what Hadoop will do is split it out across, say, 100 drives, so that when I actually need to scan that file, I have 100 disk drives working simultaneously, perhaps on 100 hosts. I can scan this file 100 times faster. So the processing goes up by orders of magnitude. This is a tremendous advantage. And the final thing is that Hadoop is improving very rapidly. So Hadoop dumps data onto HDFS. As we'll talk, in raw data, it's basically read-only. It's a classic example of an append-only approach to data processing. Making this basic design decision allows tremendous optimizations in the efficiency of Hadoop itself and the processing on top of HDFS. A good example of this is Spark. It's a project done down the street from my house at the University of California. And this is taking advantage of the fact that in addition to disk storage, Hadoop has a lot of memory lying around. Spark remembers what were the steps to do iterative calculations, remembers where the data are in memory, and then uses that knowledge to achieve speed-ups on the order of 100 to 1 for certain calculations. This is just one of many optimizations that are currently going on in the Hadoop environment. So the effect is, this is a tremendous innovation. We talk about technology and people get very excited about it. I think we all remembered object-oriented databases, C++. There were times when these were new and glittering and we thought they would change the world. Java, the language I've programmed in for almost 20 years. Hadoop is a sea change. And I think that one analogy that I think is not exaggerated is Hadoop for our industry is kind of like what happened when Galileo first pointed a telescope at the heavens. And it wasn't a very good telescope. If you've ever seen it, it was a 3-inch refractor, pretty small, not very well built by our standards today. But simply by having that telescope and pointing it to the heavens, Galileo could see the moons of Jupiter and begin to understand, begin to unlock fundamental secrets of the universe. There's a lot of data lying around. Hadoop gives us a way to look at it. And simply by having the ability to see, to have this lens, businesses can now understand much better what's going on in the world. So that's why Hadoop is important. That's why we should care. And the reason we should really care as MySQL users is we have valuable data across many, many MySQL servers. We need to get that data into Hadoop so it can join these analytics. And furthermore, we need to get it back out again so that we can show it to our users. That's why we care. So the next question I'd like to address is, what does it mean in practice to integrate with Hadoop? I think how many people are moving data from MySQL to Hadoop now? Okay, a few of you. But a lot of you have clusters and you've got MySQL. And that's actually a problem that we've been wrestling with, which is you've got a bunch of MySQL, you might have hundreds of them, you've got a Hadoop cluster. One of our customers actually has almost 2,000 nodes in their cluster. How do we join these two up? So in practice, what does it mean? Let's go into that. So this integration is really not just one problem, but it's at least 3. So the first is to get the data loaded continuously. We like to say real time. Our marketing code of ethics requires me to use that word. But really, we want to load the data continuously so that when something commits in MySQL, it gets moved to Hadoop with as little fuss as possible. The second thing is to be able to ask meaningful questions about that data and understand what it means when it's on Hadoop. This is not as obvious. How to do this is not quite as obvious as it may seem. And the final thing is that given that this is linking systems that are often very large, many instances, running over long periods of time at high transaction rates, optimizations that we can do to make the deployments as easy as possible to handle and to manage efficiently. So the first problem is moving the data. And in the beginning, there was the snapshot. And that's, in fact, how a lot of people are moving data into Hadoop. I just showed you how to do it a few minutes ago. The problem, though, is that as your data volumes become large, this simply doesn't work. So we have customers that have 7, 8 terabytes in their MySQL servers. Doing a snapshot of that over to Hadoop, if you didn't do it right, or even if you did it right, it would take days to even a week. Well, by that time, the data has no value, and it's time to do another one. So there's a problem with volume that you get. There's also issues with load in doing those snapshots. There's also a more fundamental issue, which is what you're interested in analyzing is what happened on those systems and in what order. When did people, track the exact, not the fact that you know about sales, not the current state of somebody's profile, but what were the changes that occurred. That's the information we need to capture. And snapshots don't do that. And in fact, for these and other reasons, we don't use snapshots to replicate between MySQL servers. How many of you guys are running MySQL replication? So yeah, it's close to everybody. MySQL replication is very, very powerful, and it works because there have been many, many years of engineering to create the bin log, allow people to efficiently read out of MySQL servers and get the data over to MySQL practically, or to replicas practically in real time. And there's multiple engineering groups, probably at least 6 large engineering groups working on this problem. MySQL has great replication. Can we apply this to Hadoop? Well, the answer is yes, but. And the issue that comes up is you can't just move the data across. Anybody who's done a data warehouse knows that you need to move data in big chunks. This is particularly true with Hadoop because one of the design decisions and what makes Hadoop work is that it puts data out onto those file systems in chunks, which are then read-only. You can't go out and update individual files willy-nilly. Hadoop just doesn't work like that. You need to load the file, collect data for a while, and then load it all at once. And that uses Hadoop most efficiently and matches the storage model. So in fact, when you start to look at this problem, you end up with a combined approach to load data, which actually takes the best of both worlds. So the first is you do want the snapshots. You do want the ability to dump data and load it into Hadoop, because for many types of analytics, you're not treating MySQL as a flow of transactions. It has an initial state. So some initial state, and you need to get a copy of that over, just like provisioning a slave in MySQL replication. So the dump and load is important. But at the same time, you need real-time replication or something close to it, which can then buffer the transactions and at configurable intervals, upload them. What kinds of intervals? Well, we have one, some of our tests running at one of our customers, we're buffering about 2 million transactions and loading them all at one crack. So the number of transactions that you may need to buffer can run into the millions in some cases. So with this approach, you've basically, conceptually, you've got the ability to do the integration. And the fact is, right now, here today, you can download open source code which does exactly this. So very common program that's used for this problem is Apache Scoop. Very popular, it's in all the Hadoop distributions. That's out there, that's your provisioning. At the same time, with the new features that we put into the Tungsten replicator, you now have the ability to replicate the changes after you've provisioned over to Hadoop. And I'll just point out, this has many features, but I'll just point out a couple. One of the things that is important about this and gives you a flavor of some of the details is we have programmable load scripts. Hadoop clusters all tend to be a little bit different. There's sort of weird differences between distributions. You can adjust the load scripts, just a few lines of JavaScript code to adapt to what you want to do. The other thing we do is we generate CSV automatically. CSV is kind of the language of the realm for many Hadoop applications. So what we're doing is taking the bin log data and turning it into CSV. So that's the first step. You've actually got a mechanism to do this full integration now. So the next question is, what do we do with the data once we've got it over to Hadoop? So everybody here is used to running a select and just seeing tables. That's one of the great things about Hadoop. You're curious about what's in the data, log in with MySQL, run a select, there it is right in front of you. Well, in Hadoop, it's not like that. This Hadoop works off CSV. It's not the only format it uses, but an awful lot of Hadoop data is in CSV. This is the assembler language of data management. And as soon as you move that data over, if you're going to deal with that raw data, you now need to worry about a bunch of really, really niggling issues. For example, how do I do file separators? I'm actually using a printable form of this. Hadoop actually likes hex 1s to separate columns. This is just one of many, many issues that you have to deal with the CSV. So you're looking at raw data, and this stuff is just unconsumable, especially if you're a human. The second thing is it's not just, this is simple data, this is a snapshot picture. What we're really interested in loading, of course, is also transactions on that snapshot. And one of the things that you can do with the bin log is you can turn the bin log into a set of inserts and deletes. So for example, so you get a CSV record for an insert. It's prefaced with an I. An update is a delete followed by an insert. This creates more basically unintelligible data in CSV. So the problem that we have now is how can we put some structure on this so that we can actually even look at what we've got and understand and work with it. So fortunately, there's a fairly simple solution. We need to add more information to what we're replicating across between MySQL and Hadoop. We need to move metadata. MySQL has definitions of tables. It is very easy to read them out of the information schema and generate schema definitions for Hadoop. One of the things that we've done is generate Hive schema definitions. That allows you to go ahead and look at your data in Hive. So now you've got something that you go from having that raw CSV data, you've now got something where you can actually run a select statement and it looks like what you're accustomed to seeing in MySQL. The problem here is that you're not really done. Once you can see the data, you can just realize, hey, we've got a lot more work to do. And the work that you have to do is now we'd like to construct pictures of tables as for example, in their exact state as of a point in time. So not just the dump, but also the effect of adding transactions to it. How do we do that? So this is where we can start to use some of the power of Hadoop itself. And there's a very powerful, MapReduce is a very powerful programming model which allows us to solve this problem quite efficiently, or at least efficiently for human beings. So we can just grab all the data for a particular table. We just do a union join. That's pretty simple to do in Hive or any of the other tables. You then do what's called a shuffle. This is a step in MapReduce where you sort, and in this case by keys. And we also sort by the transaction order. So imagine a bunch of sales. For every customer, for example, their key, we would support any information about that associated with that key in transaction order. And then we hand it to the last step of MapReduce, which is the reduce. And that step looks at these lists by key. And if the last thing in the list is an insert, we take it. That represents the state of the table. If it's a delete, we throw it away. I sometimes call this set-oriented update. We've used it for a couple years now in our data warehouse loading, but this is a very powerful mechanism, and it allows you to take that bin log, which consists of all these updates, inserts, and deletes, and apply it to the snapshot and get the exact state of the table, as it, actually, if you want, exactly as it showed over in MySQL. So this is very powerful, but the interesting thing is that it's better than it sounds. So how many people in this room have dealt with broken MySQL replication? So I think if you didn't raise your hand, you're probably not using MySQL replication. So there's just things like primary keys, duplicate primary keys, a classic error. I think I had a support case on that. I was looking at a support case on that 3 days ago. This stuff comes up constantly. You also have problems with MySQL replication where if you're trying to provision a copy out onto a replica, it needs to be transactionally consistent. Something that comes up constantly, hey, I didn't quite get it's not actually consistent, maybe I was actually writing to this copy as I was trying to do the dump and load. And again, you get messed up replication and you waste a bunch of time. What's cool about this is actually, as we integrate from MySQL to Hadoop, these problems, which are so painful in MySQL, they actually go away. And this is a very, very interesting consequence, because basically we're reconciling the data and creating that view of the table just by doing a sort. And it doesn't matter if we're scooping the data, if we're copying it across, as long as replication is running at the same time, it does not matter if that data that we scoop is consistent. It just needs to be some picture of what's going on in the tables. It could be a picture taken over 24 hours with changes on the tables. As long as we have the log and we can apply it to that change, all the duplicates and the inconsistencies will cancel each other out. And what that means is that we can replicate out of MySQL, and the problems that we have traditionally of dealing with locks, transactions, pausing processing to provision, you don't have these problems in this integration. It just works. Similarly, on the Hadoop side, you're loading into HDFS. There's no constraints. You're just loading raw data. So things like lock-wait timeouts, hey, they don't exist. Duplicate primary keys, no big deal. It gets sorted out in MapReduce. This works. I am not saying that this is necessarily easy to do, especially on large scale. But this is an integration. When you see stuff that works this well at this level, it's a sign these integrations are going to be successful, and in fact, I would say very successful. I think this is good news for MySQL. In fact, it's one of the, really, I think one of the things we've learned is that the challenges that you get actually have to do with exactly this, what you do on the Hadoop side to manipulate the data. So in addition to the replicator, we are publishing tools that we use to do these types of operations, including not just the materialized view generation, but even sort of simple utilities to compare data, so you have the ability to test stuff. It's out on GitHub, it's Apache licensed. Feel free to take it, use it, copy it, do better versions. We'd love to hear from you. Finally, optimization of large-scale environments. So we know that fan-in replication is something that's appearing in the in MySQL itself. You can do this with the replicators. This exists. There's various features, like recently in our own replicators, we updated them to make them auto-recover so that they'll stay up with very, very large, through thick and thin, even when various glitches occur. MySQL, of course, does this very well. There are other types of optimizations, and these are things that I think are important to concentrate in the future. So I showed you this implementation, which included Scoop. It included the real-time replication. It included perhaps moving the metadata through separate tools. What we really want to get to in these large implementations, and to make this a powerful and efficient integration, is to do what I call single path loading. So in other words, you have a replication stream and it covers everything. How would this work? Well, let me give you an example. We're working on a feature right now for one of our Oracle customers that's called parallel extract. It basically does what Scoop does, where it goes and takes snapshots of a bunch of tables, divides them up into chunks, and then the whole result runs through the replication log, so it has exactly the same transformations applied on it that the regular real-time, sort of the updates do. So this is already reducing the number of tools you have to manage by 2. Moreover, if you think further out, we want to take that single path loading and we want to turn it around and come out of Hadoop. As Peter says, you have interesting conversations at this conference. I've already talked to 2 people who have exactly that problem. So the integration needs to go both ways. So this is something that we're focused on. We actually have a pretty big, pretty long roadmap for Hadoop. We did a lot of stuff in Q1. This stuff is actually out. One of the reasons that we're able to talk about this is actually out. Customers are using it. We have many things that we'll continue to operate on, but all with the vision of making this as simple and efficient as possible. So we'll continue to work on that and report back at later conferences. So the final question is, how do we all prepare for this integration? If you buy that it's something that's important to do, if you buy that, hey, these are the practical issues you have to overcome, how do you get ready to do it? So if you're a user, it's just a matter of following best practices. A simple example, time. If you set your servers to use UTC, there's just a whole variety of sins that are covered up by this. MySQL does timestamps. They're normalized to UTC. MySQL does dates. They're not. They're actually associated with the time zone, but MySQL doesn't remember the time zone. When you dump them to CSV, they get all mixed up. So just having consistent time, being consistent about character sets. Row replication, there's always been kind of a choice between statement and row replication. Well, this is something where row replication really, really helps. So we're going to begin to see more of a push, I think, in this. And then obviously cluster your data. There's nothing worse than setting up this whole integration, everything's working great, and you lose the source MySQL servers. You not only don't have reports, you have a bunch of other problems as well. So just best practices. Next question is, what do we need to do to MySQL? The answer is nothing. MySQL already works. And the reason is that there were design decisions in MySQL taken many, many years ago to do replication, to create the bin log, to implement row replication. We are now benefiting from those decisions, and it's simply a matter of building the mechanisms that can build on the foundation that MySQL has already laid. I think this is a really important point, because MySQL is already well positioned to take advantage of to enable this integration. And then finally, what can the community do? Well, I think this is an interesting question. Obviously, what I've been talking about today, what we're working in both as part of our business, but also as our contribution to the community, is to get this fast, heterogeneous replication working into Hadoop. That's something that we're very focused on. But I think the other thing, and this was the thing that I learned personally, is that a lot of the work is actually on the Hadoop side. You can get raw data over, but transforming it into things that are easy to look at, understand, manipulate, that's a place where we have work to do. And I think that it's an area where the MySQL community is particularly well positioned, large number of people using MySQL. We can all do projects to help solve these problems. And in fact, there's a final thing, is that we need competing solutions. MySQL replication is great because there's a bunch of it working on it, and we're constantly looking over each other's shoulders to make sure the other guys are not catching up too fast. We need to do the same thing with Hadoop. So as much as it pains me to say it, because I run a business, we need competition. It's good for our products. It forces us to make them better. It's good for the MySQL community. So having more people working on this problem is very important. So the conclusion, before I thank a couple people, is Hadoop is for real. There are technology changes and technology changes. This is one that's actually important. And it's one that's going to figure in our lives as we manage data going forward. We need to adapt to it. The second thing is that the challenge and the thing that we need to optimize now is we need to move data and we need to be able to work on it inside Hadoop. These are important problems to solve. The third point, and I think this is actually the really important one for us as people working with MySQL, wanting it to prosper, wanting to continue careers in this part of the data management field. MySQL became great because it got a lot of really basic things right. It was very easy to set up and use. In fact, that's how Peter got into trouble, I would guess, because you could just download it and it would just pop up and run. It was joined at the hip with PHP. So all those people who are writing PHP, it was easy to talk to MySQL. It had replication. That was a really great decision and accounts for an enormous amount of usage. I think Hadoop, being able to integrate easily with Hadoop, looks like another advantage, of a tremendous advantage of MySQL. I work with a lot of database types. I can tell you that the database types that I work with, these include Oracle, they include things like Vertica, other transaction processing databases like Postgres. MySQL is ideally positioned because of the fact that we have this very powerful replication capability and a very stable and well-developed database to take full advantage of this Hadoop integration and make Hadoop MySQL be the database of choice for people who need to load data in and out of Hadoop. So I'd like to finish by thanking some of our customers. Hadoop is very complex technology. Two in particular I'd like to call out. I've been working very closely with folks at Groupon. Chris Schneider, who's here, I don't see him out there, but he's doing a talk later today on Hadoop for MySQL people. I encourage you to go. His colleague is Suresh Antony. These guys, anything they say about Hadoop is worth listening to, so definitely go to that talk. Another company is Booking.com, one of the sponsors of this conference. I've been working with Eric Herman. He wasn't able to make it to this conference, but some of his colleagues are here. I want to thank you all. I look forward to meeting you here. We really appreciate the fact that you've been able to teach us what needs to be done here. So, and then beyond that, of course, all our other customers. You've helped make our products great. So with that, we've got a couple of talks. There's Chris's talk this afternoon. We're doing one on the details of real-time loading from MySQL to Hadoop. I invite you to attend. That's done by a couple of my colleagues. And at this point, I'm done. Thank you very much for your attention. Have a great conference.